So let's kick it off. Thank you guys so much for being here. It's awesome to see such a good group at 8 a.m. So thank you guys all for getting up early. I must admit I'm from Boston, so this is 11 a.m. for me, so I'm like, this is great. But especially for people on the West Coast, thank you guys for getting up so early. So today I'm going to be talking about population health management using Azure Data Lake Analytics and Power BI. So my name's Danielle Dean. I'm a senior data scientist lead at Microsoft. What I do every day is I actually work with external customers using Cortana Intelligence Suite, Power BI, all of our analytics products to build out real analytics solutions for our customers, especially in the healthcare space as well as with IoT kind of solutions. So although I sound like I'm in a consulting group, I actually work in the product org. The reason why we do this is we actually want to work with our customers, make sure that the products are working for real life scenarios, and then make sure we get that feedback back to the product so we can improve them over time. So I've been working at Microsoft for about 3 years now, and I'll say it's unbelievable how fast all of this stuff is changing. I work inside the product org at Microsoft, and I can't even keep up with all the analytics technologies that we're building at Microsoft, let alone people outside the group. So it's kind of amazing. And today I'm going to be talking about Azure Data Lake Analytics, which is a relatively new service to be able to do data science type solutions using Cortana Intelligence Suite, which connects to services like Power BI. So let's get started. So I'll be going briefly over what population health management is and talking about some example solutions, really trying to inspire you guys with the type of work that you can do in this space. Then I'll be talking briefly about some trends that are driving transformations in healthcare, followed by some deeper dive solutions, so some example solutions, and I'll be actually going into the portal to show you, into the Azure portal to show you guys how some of this stuff works. So Azure Data Lake, as well as how you can actually use R, which is a really nice open source language for statistical computing and machine learning, and then showing some more demos. And hopefully I go through the material fast enough to end with an inspiring session around deep learning and what you can do with AI and population health management. So that's the goal for today. Hopefully you go away from this session both being inspired, also getting some material that you can leverage, and then pointing to some resources that you can learn a lot of this stuff and then build some of this with your own businesses. So healthcare is expensive, as you guys all know. It's around 1/6 of the economy in the US at least. And there's been a large shift recently from fee for service, where you just pay for what you get, to really trying to pay for value. And what this is really driving is a lot of healthcare institutions are really trying to improve outcomes. Now this is obviously really good for us. We want our outcomes to be improved. But really to do this, we need a lot of tools to help manage and control the cost to help improve outcomes. Now, traditionally, population health management has been about tracking, monitoring, benchmarking, a lot of historical reports looking back in time, aimed to improve outcomes while managing costs. Now, in order to do this, we have to do a lot of things. There's a lot of disparate data sets, lots of multiple sources. We have to bring them together. There's structured data, there's unstructured data, there's semi-structured data. I have to integrate these all together and also have to be able to analyze them in a fast way. Now, population health management, as I've been mentioning, has been really focused traditionally on these reports and interactive dashboards. But what I'm going to be talking about today is moving into the space of even predictive models and even recommendations and automation. So in addition to doing things like what happened, why did it happen, which are very important and foundational, we want to be able to predict what happens in the future. What's the length of stay of somebody who's, when they come into the hospital, can we predict what their length of stay is so that we can optimize the bed allocation? Can we do things like predict their readmission likelihood? Do we want to keep this person longer, or do we want to put them into an intervention program? And then even doing recommendations and automations such as that intervention type of program. So really trying to go down that spectrum for population health management. And a lot of that, the trends that we can do and the new transformations that are happening in this space are due to 3 broad trends. And I know you've heard about all 3 of these, but let me just reiterate because it's very important for the rest of the session. The first is big data and IoT. Now, IoT is happening everywhere, Internet of Things, right? I even have this little tracking monitor. I'm not wearing it right now because it could interfere with the mic, but it tells me when I'm not standing up straight. So it's amazing what kind of devices they have today, and all these bands and Apple Watches and all this stuff where you can take all this data about health and really try to improve outcomes using that. So big data and IoT. Another area is genomics, the amount of data that's generated by genomics. Somebody said something around the world of 15 petabytes of data a year, petabytes. I didn't even know what that was a few years ago, petabyte. And that is every year we're getting this amount of genomics data. So being able to analyze that data is very important. Now the cloud is really opening up a lot of opportunities for businesses. Rather than having to acquire all the hardware to simply store all this data or analyze all this data, use services like Microsoft's Azure to do all that storage and compute for you. It's a lot easier to get started, it's faster, you only pay for what you use. If you need to store things for long periods of time but don't need to do compute on them, you can pay for the storage and then do the compute separately. So the cloud is really opening a lot of opportunities in this space. And then machine learning is also doing a lot these days with looking at that predictive models and recommendations and automation. So really enabling a lot more types of use cases, and I'll tell you some more about that soon. So there's a couple quotes here that I like to see. So medicine has been a clinical science supported by data, but medicine is about to become a data science supported by clinicians. So it's really, I think data is going to transform healthcare. It's already starting to, but we're just at the beginning. Data is going to become more and more important in healthcare in the future. Now, traditionally, you've had the data being collected, going back to an analyst who would do these reports. But in 10 years, data science and software are thought to be able to do more for medicine than all of the biological sciences together. Now, this is obviously a big statement, but it just goes to show you the point that data is really important and we can do a lot with it. So I just want to tell you a couple of quick stories to illustrate this point. So this is an example where we're trying to identify the optimal LASIK treatment plan, so LASIK eye surgery, in order to be able to see better. Now, a lot of these surgeries are successful today, which is great, but there's a lot of side effects that happen. Now, if we can use data to actually understand what are the parameters that go into that surgery, what are the tools, what are the settings, what are all of these things that go into that, and then we know the historical outcomes of what happened to that patient, what the side effects were if they had side effects. And if we can use that data to build models that learn the relationship between those different settings of those tools and what the outcome is, then we can actually do what-if analyses to determine what will happen in the future. What should the settings be for this new patient? They were similar to this person, similar to this person. Let's combine all of that data together and learn what the optimal settings should be for that person going forward. So really trying to improve the outcomes for that person. Another interesting example is early screening for dyslexia. Now, this is a really nice example where dyslexia it's incredibly common. And unfortunately, the later you find out, the harder it is and the not as good the outcomes are. So if you can identify this really early, you can do a lot to improve the outcomes. Now, it's hard to identify early. In fact, teachers and even people who are really well versed in this, it's really difficult to determine. But you can do some amazing things with eye tracking. So again, this is a situation where we're tracking eye movements, and then we know based on historical data what people ended up with being diagnosed with dyslexia later in life or not. So we can use that historical data and those relationships to be able to predict which person has dyslexia and then start early treatment programs. Another example in the genomic space is about analyzing all that vast genomic data. I mentioned earlier about the 15 petabytes of genomic data every year. It's amazing how cheap it is to analyze your genome these days. You can send in a little vial and get results back, for hundreds of dollars, maybe even less by this point. But that is a ton of data, and not all universities have, or even institutes or companies have millions of dollars to buy all this massive hardware. How do we store all this? Then you have to provision it. Then you have to start a whole IT organization to set up the infrastructure, to set up security, control all of these things. It's incredibly complicated to set that all up, especially if you're a small institute looking to do this type of research. Now, with the cloud computing power and these services, these platforms that do all of this for you, you can really set it up a lot faster and enable these types of analytics. It's amazing what you can do with genome analytics on the cloud. And then finally, the last example I want to touch on is in the predictive maintenance space in healthcare, where there's an interesting company that's building these smart fridges for vaccine management. Now, vaccines around the world often have to be stored in fridges, temperature controlled, but there's a lot of issues related to what happens if you lose power, what happens if the temperature fluctuates slightly, and how do we know and monitor and react to all these things. You can lose lots of money if you just simply lose power for short amount of time. So using IoT, collecting data about all of those devices, all of those fridges, you can proactively maintain them, make sure that you fix them before they actually fail in the future. So even doing forecasting into the future of when issues are going to happen. So some pretty interesting things you can do in the vaccine space. Now, I'll be going into a little bit more detail after this about the Cortana Intelligence Suite. Now, there's a lot of services here. I'm obviously not going to touch on all of them today, but the main focus is the Cortana Intelligence Suite is a suite of services built on the Microsoft Azure platform, that cloud provider that I was talking about. Now, in the Cortana Intelligence Suite, it services from information management, so doing things like reading data in, cataloging your data, ingesting the data, orchestrating it, to big data stores, some of which I'll touch on in the demos. So things like Data Lake Store, SQL Data Warehouse, Document DB for JSON type storage. And then a lot of analytics services from Azure Machine Learning Studio and a machine learning service that I'm not even going to talk about today, to Data Lake Analytics, which I'll be demoing shortly. HD Insight, which is basically a MapReduce framework on the cloud. Stream Analytics, which I'll also be demoing in a little bit, allows you to do SQL-like processing on real-time streaming data. Really powerful, but also very simple to do. Azure Analysis Services, which I'll mention later, and I know there's been some talks in this conference about that. And then a bunch of intelligence services from the cognitive services, which allow you to do things like sentiment analysis, face recognition, APIs that are actually already pre-built. You don't need to know anything about machine learning in order to utilize these services. The bot framework, which allows you to build things like live chat frameworks, and then Cortana and obviously Power BI. Now, I'm going to be talking mostly in the rest of the talk about big data as a cornerstone of the Cortana Intelligence Suite and demoing what you can do with these different services. Again, a lot of these services are relatively new. Data Lake, Azure Data Lake came out about 2 years ago, a little bit longer, G8 in the last 6 to 8 months or so. And it's really amazing and powerful tool, what you can do with Data Lake and Data Lake Analytics. So I'll be touching on those mostly today. Now, big data in general is driving a lot of transformational changes. Now, traditionally, we had things like relational data, specialized hardware, operational reporting. Now, in this big data realm, we're moving to more commodity hardware, using lots of different data, using different structure, and really just making sure you keep all of that data, store it all in its raw format, especially when we start to move into the machine learning and AI space. It's amazing how important it is to build up that data over time. And so with this big data world, really capturing all of that, leading to more experimentation and hopefully intelligent action. Now, unfortunately, big data sounds cool, but it's really hard in practice. You need skills, you need capabilities. How do you get value out of all that data? There's some really funny and interesting stories about people doing these really cool big data analyses that lead to these interesting results, but they're completely meaningless because they're looking at correlation rather than causation, all of these issues that happen in the big data space. So determining how to get value and doing the analyses right is often very difficult. And then, of course, how do you integrate with the traditional environments? And that's also definitely a big challenge. Now, Microsoft has done this before, and I'm going to tell a quick story to show you how we got to Azure Data Lake. But we needed to do this internally ourselves. We needed to better leverage data and analytics. We needed to do more experimentation. We have all of these different services. We have Windows, we have Bing, we have Office 365, we have Xbox, we have Exchange, we have tons of data. So what we did was we designed a data lake for everyone in the entire company to put their data into. Now, this started a few years back on-premise, not in the cloud, and we built our own services where we could store all of this data, petabyte scale to exabyte scale data within Microsoft. And we actually had 10,000 developers who were analyzing this data at the same time on this one huge, massive data store. Now, what we want to do is we want to take what we've learned on this journey, the technologies, the tools, how we store this data, how we analyze it, how we enable 10,000 developers to analyze data at once, and we want to bring this externally to our customers. And so that's what actually led to Azure Data Lake. Now, Azure Data Lake is 3 services that I'll mention briefly. So the first is Azure Data Lake Store. So this is a no-limits data lake that powers the big data analytics. So you can have petabyte size files, trillions of objects, a scalable throughput. But it works like HDFS, so it's the HDFS compliant, so you can still use lots of other open source tools to connect into your Azure Data Lake Store. So it definitely works well with open source. Always encrypted, role-based security, and of course enterprise grade. Now the second layer of Azure Data Lake is this Azure Data Lake Analytics. This is a no-limits analytics job service. Now, what is really cool about Azure Data Lake Analytics is you can develop massively parallel programs really simple. And I'll show you some example USQL queries in a little bit. And another really nice part is you can debug and optimize your programs much easier than you can do in the traditional MapReduce or Spark type framework, because you can actually replay jobs really easily and go back. You don't have to tune and then redeploy. So there's a lot of really nice things that you can do. Now the last part of Azure Data Lake is Azure HD Insight. This is the traditional clusters as a service where we have a MapReduce type framework. And this is really a really cost-effective way of starting on the cloud. If you have a lot of MapReduce type code already, if you're using Hadoop type services, then Azure HD Insight is often the first place to start, rather than your Azure Data Lake Analytics, because you have this type of code already available. But I'm not going to go too much more into that today. So as a framework, I just touched on 3 services: Azure Data Lake Analytics, which is how you do your analytics; HD Insight, which is your clusters as a service; and then underneath both of these is your Azure Data Lake Store. Now remember, this is storing and analyzing data of any type, any kind, structured, unstructured, semi-structured, any size. So there's no limit on the size of files, no limit on any of those aspects. So you can also develop faster. We say that there's no learning curve. I'd say no is probably a little bit of an exaggeration. But we have SQL-like language, so it's a lot easier to get started. And then it also can obviously dynamically scale to your needs. Now, I mentioned USQL a couple times. This is a really nice language it's familiar. It's SQL-like language. It's also very extensible. So it unifies the declarative nature of SQL with the expressive power of C#. Now, what I really like as a data scientist is you can also integrate USQL with existing .NET libraries, as well as R and Python, which are 2 open source statistical machine learning frameworks or programming languages. So within USQL, you can call out to those open source languages and scale out your processing, again, on petabyte or infinite scale. And because it's this framework for you, you can massively parallelize code. And there's even cognitive capabilities built within Azure Data Lake Analytics. So if you've heard of those cognitive services that allow you to do things like sentiment analysis, facial recognition, rather than having to call out to those cognitive APIs on lots of data, those functionalities have been built into Azure Data Lake Analytics as custom functions, so that you can run that on your petabyte scale data. So you can massively parallelize code easily. You don't have to worry about how any of that is done. It's done under the hood for you, and then you can also use those types of capabilities. And I mentioned earlier about this debuggability. I don't know if that's even a word, debuggability. But you can easily debug and optimize your code. There's deep integration with Visual Studio Code. You can also run it from the portal, but definitely recommend doing this from Visual Studio type framework. It's integrated with USQL, and you can replay the jobs back, see where the bottlenecks are, see what's happening when you're doing your job, and what's taking so long, and actually understand that so you can optimize your code. Now, it's also a really high availability. Obviously, this is all managed, monitored, supported by Microsoft, so you don't have to worry about doing any of that yourself. You don't need IT resources to upgrade and patch, and the deployment is automatically monitored for you. Now, in addition, the one really nice part is this separating compute and storage aspect, which really lowers your total cost of ownership. So you don't pay to have this huge Azure Data Lake Analytics account all the time. You just simply pay for your storage, which is incredibly cheap, and then you pay for the compute when you do it. So you don't pay for that unused cluster capacity. You just pay for the compute that you do when you run it. So you can independently scale and utilize those storage and compute. So to refresh, I talked a lot about Azure Data Lake Store and what you can connect to. So as a reminder, you can connect to any type of data, structured, unstructured, and put that in Azure Data Lake Store. For those of you who are familiar with blobs, Azure Blob Storage, you can think of Azure Data Lake Store as kind of like a version 2 of that. There's differences in a lot of detail I'm not going to talk about today. But Azure Data Lake Store is this Hadoop distributed file system and no limits on any of that size. Now, in addition, you can connect on top by many different ways, whether that's Azure Data Lake Analytics, as I'll be talking about, as well as HD Insight. There's a lot of other frameworks that you can also do to connect on top of your Azure Data Lake Store, which I won't even touch on, such as Azure Machine Learning Studio, which can connect to your Azure Data Lake Store. Now, Azure Data Lake Analytics, well, I mentioned it, I talked about that use SQL, how you can extend it with R and Python, for example. You can also run Azure Data Lake Analytics on top of lots of different storage layers, combine data from different places together, which is really pretty cool and powerful. So, for example, you could have data in Azure Data Lake Store, you could have Azure data in a SQL data warehouse. You want to join those data sets together and do something with that new output. You might have some data in a database that enables easy reporting and connection to an application, but you need that data also to do some historical insights. So with Azure Data Lake Analytics, it allows you this power to connect to all of these different sources and do powerful things on top. So there's a demo, and I'm not going to go into it today, but at this link and the slides will be available, so you'll have all of this for reference. There's this demo at DataAmp just a couple of months ago where a lot of these services were talked about for the first time, where we actually had 2 petabytes of data in an Azure Data Lake Store, and we were showing how you can connect all these different services together to enable insights. In this example here, it was about service logs and service telemetry, so trying to improve customer support. And so what we did is we had data in this Azure Data Lake Store, and we had Azure Data Lake Analytics on top of it. And now with Azure Data Lake Analytics, we had some R jobs where we were doing forecasting of support logs. Basically what we wanted to do is forecast the amount of support that was going to be needed in the future so that we could proactively schedule the amount of people to answer phone calls about support. So we were using Azure Data Lake Analytics on top of this Data Lake Store. We also needed to connect to data that was stored in this case, it was reference data stored in an Azure SQL database. So with this federated uSQL join, again, you can connect to these multiple data sources and do analytics on top of them. So we're connecting data in Azure Data Lake Store, Azure SQL database, and connecting them together through some join queries and other types of queries that were done in Azure Data Lake Analytics. Then we connected that data out to a SQL data warehouse. Now, we didn't actually move data to a SQL data warehouse. Actually, through Polybase over Azure Data Lake Store, which I won't talk about much today, we can actually view data that's in that data lake store in the SQL data warehouse, just like it's a SQL table. So we don't actually have to move data, but we can just view it using actual SQL language in SQL data warehouse to view that data. Now what we can do is we can use Azure Analysis Services to actually put an in-memory cache on top of that data in SQL Data Warehouse to enable billions of rows interactive queries in Power BI, which is incredibly powerful. So using these different services together, we had 2 petabytes of data in Azure Data Lake Store. I don't think I can emphasize that enough, 2 petabytes. It's kind of incredible how much data is there. But through these different services and putting them together in the right way, and then with Azure Analysis Services, which I know there's a bunch of other talks at the conference today, with using that tool, we can, again, enable billions of rows, interactive, lightning speed queries in Power BI, which I know a lot of people say, oh, Power BI, that's, it's really awesome, but it's not for big data. This is big data in Power BI, so it's really pretty incredible what you can do using these services together. So with that, I want to touch briefly on R, because I'm sure there's at least a few folks here who are just a little bit familiar with R, maybe don't know too much about it. And I'm going to be talking about R in the demos with Azure Data Lake. So R is a programming language, especially for statistics and machine learning. It's become incredibly more popular over time. You can see some charts here of about 75% of analytics professionals are using R today, and even about a third are using R as their primary tool. I'd say R and Python are probably the 2 most popular data science languages. And R is even becoming popular in like a programming language survey, not even about statistics and machine learning, but just popularity in general. Now, why has it become so popular? I like this quote: "I don't usually analyze data, but when I do, I use R." It's the most interesting language in the world. So R, it's free, it's open source, it runs on almost any computing platform. Its functionality is really modular, it's contained in packages. It's really become a really vibrant user community and really powerful graphics that you can do. Now, it's really powerful. It's also really quirky. There's, especially if you come from a programming background and then you learn R, there's some really weird things like a period is just a simple separator, just like a character, which for a lot of programming languages, that's very strange. And so there's a lot of quirky things about it, but it's really powerful to do machine learning. But unfortunately, the objects generally have to fit into physical memory. And so R, again, is one of those tools that people say, oh, you can't really do big data with R. But using tools like Azure Data Lake Analytics, you really can, so marrying them together. So the R, it's statistical software, data visualization toolkit, programming framework, programming language, and then there's this thing called CRAN, which is this package system. And the number of packages has increased exponentially. So just to show you some example packages, we have things from cluster analysis, clinical trial design, optimization, mathematical programming, reproducible research. The amount of packages are just unbelievable because the community is becoming so big and improving over time. So really R is popular because of these packages. You can simply install and leverage them and then do really interesting and powerful things as a result. Okay, so I want to get into the demos. Now I'm going to show or talk about 3 main demos today. These demos are going to be available in the Cortana Intelligence Gallery. One of them is already available there today, but the others will be coming soon. So this is gallery.cortanaintelligence.com, and again, these slides will all be available to you. But I'm going to give you a sneak peek at the types of demos that will be available. Now, the demos I'll be showing are what we call solutions in the gallery. These solutions are neat because they're basically with a one-click button, and then sometimes there's a few steps in between. But for the most part, a 1 to 2 click button, you actually deploy all of the demo resources in your own Azure subscription. So you can see an end-to-end solution. So in addition to obviously all the individual services have really nice documentation and tutorials and so forth, but sometimes it's hard to say, okay, I have my Azure Data Lake store, I get that. But then I have this. How do I put them together? How do they connect? So these solutions are end-to-end scenarios that show you how all the services work together. Now what we do is because we want to show you this working on data, we actually give you a data generator. So when you click the solution to deploy in your own Azure subscription, it comes with a web app that's running a data generator that's feeding data through your end-to-end solution. So in these examples, we've taken either publicly available data or we've simulated data to give a sense of how the data is going to flow through the system. So again, these demos, if they're not available already, they'll be available soon in the Cortana Intelligence Gallery in the Solutions section. Now, in addition to having that one-click deploy experience, a lot of the solutions have an underlying GitHub with manual instructions of how to create the entire thing from scratch. Now, this is not something I'd say go do in an hour because I'm talking about a lot of services here. You have to click a lot of buttons to do it all manually. So they're really not meant to, the one-click deploy or the solution experience is meant to get you started quickly. And then the GitHub is meant to say, okay, that was cool, I really want to learn it for real this time. How do I walk through and do this all by scratch? So that's what the GitHub is for sitting down and really getting to know the details of how these things work. Okay, so now I'm going to show a demo in action of and show you in the Azure portal about Azure Data Lake Analytics. So in this solution, we're using data that's simulated based on healthcare HCUP data as a publicly available data source, inpatient data, and we're reading this data in through Azure Event Hub. So we're sending data into the cloud through this service. Then we're using Stream Analytics to do 2 things. The first thing we're doing is we're sending data right to Power BI, so we can actually get live updates on a Power BI dashboard. So this is the connection between Azure Stream Analytics and Power BI. Now that's our hot path, so data coming in that we want to visualize right away. Now our cold path is where we set data out from Stream Analytics down to our storage layer, our Azure Data Lake store. So in this case, we are saying get this data in, and in most cases, we're basically doing something like a select star, although you can do much fancier things in Stream Analytics. We just want to read that data in and pump it down to our storage layer. Now, once data is in Azure Data Lake Store, what we're going to do is we're going to use Azure Data Lake Analytics to analyze that data, query lots of different data sets together. We have lots of different data sets coming in. We want to merge those together, and we want to do a machine learning prediction. In this case, we're doing a length of stay prediction. So when patients come in to the hospital, how long are they predicted to stay based on what condition they have, all of the factors about that individual. You know, we've built a model based on historical data that said, based on these factors, this person stayed in the hospital for 2 days, 4 days, etc. So using that historical data, building a machine learning model, we then want to deploy it on that new data coming in through the system to be able to predict in the future. So we've taken that machine learning model that we've built using open source R, all those cool packages that we showed you before. We used open source R to build a model, and now we want to use Azure Data Lake Analytics to deploy that model. And so we do that with Azure Data Lake Analytics with the use SQL query that calls out to an R script. And then we use this service called Azure Data Factory to orchestrate it. Now it's nice to have a script, but that script has to run. It has to run on a schedule. And so what we do is we use Azure Data Factory to say, run this script every 15 minutes. So we have the data coming through Stream Analytics, putting it out to our storage layer. It's collecting data over time, and then every 15 minutes, we take that last slice of data that's come through, we run a machine learning model, we get the predictions back out, and then we simply store it in a location in the Azure Data Lake Store, and then connect the results to Power BI so we can visualize them at the end. Let me switch over. Okay, so here is my Azure storage. This is my personal storage. So this is the real deal. And again, you can see lots of data in here. And what here, this is a resource group which contains all of the services for this solution. So this is the type of thing where you can tell there's a lot of different services I'm using here, and to do this all by hand would take a while. So that's again why these solutions are nice, because they will deploy them in your own subscription for you, so you can see how they all work together. So again, let's look at the Stream Analytics to start. So remember, we were ingesting data in through Event Hub, through Stream Analytics, and outputting it both to Power BI as well as to our storage layer. So this is this hot path query, where again, it's really basically a select star into an output, which is a Power BI output. So we can visualize it right away in our Power BI dashboard, and it will update all the time when data comes through. So really simple query here. I'm really not doing anything fancy, but you could do a lot more things. So for example, you could group by 5-second windows. So can you imagine you're trying to write data on streaming in data, or you're trying to process streaming data. It can be really hard, but using SQL and using a time function, you can simply do things like, I want to look at this grouped average outcome every 5 seconds, and output that to my Power BI and view that over time. So with SQL-like language, through these time functions, so you can group by time, by enabling time to be in that SQL, you can use SQL-like language to analyze data in real time. So that's Azure Stream Analytics, and that's the hot path. So let's go back here, let's look at the cold path. It's very similar, where we're just taking data in. In this case, we have a few different data sets that are coming in. We have some costs, some charges. We also have some details about the patient outcomes, and we're taking all those different data sets in, and we're outputting them out to our different storage layers, different tables. So that is Azure Stream Analytics. So now, next, let's look at our Azure Data Lake Store. So in this case, I want to show you a couple of things. So one is just an example output, just to give you a flavor of what it looks like. Again, this is simulated data, or based on some publicly available data, so don't go look at this data and try to come up with amazing insights. It's fake data. But here you can see an example where there's nothing really to show you much here, except that we're outputting data back out, which is the data that we're going to visualize in Power BI. And you can see it's updating at all times, so it literally updated just a couple seconds ago. So that was our data for Power BI. I also want to show you an example R script. So these are some different R scripts we have in here. These are deployed again through Azure Data Lake Analytics. So that use SQL script will basically have one line in it that calls out to that R function. And then we do some things like we say, put this R script on each hospital, because we want to predict the length of stay for each hospital. And there's a lot of detail here, but it's not super important other than to show you this is just regular open source R that we're applying on really large data using Azure Data Lake Analytics. So that was our Data Lake Store. Let's go back here. I'm going to show you Azure Data Lake Analytics. just to show you some sample scripts similar to what you saw earlier. And there's a lot of tutorials on how to do these individual services. So they give you sample data that you can copy over and then play around with Azure Data Lake Analytics. And again, I'd really recommend when you're starting out with these services to use Visual Studio or another developer that has integration. You can do it from the portal and it's okay, but the experience is a lot better being able to debug and do things like that from an environment like Visual Studio. So you can see it's, again, SQL-like language that we're doing here, just extracting some data and outputting it to a file. So that is our Data Lake Analytics layer. Next, I want to show you our data factory. So remember just to refresh, we had data coming in through Azure Event Hub, through Stream Analytics. Stream Analytics was querying that data in real time and outputting it to PBI, as well as to our storage layer. Now we have all this data accumulating over time, and we have all these nice SQL scripts that use R to forecast, to be able to predict the length of stay for these patients that are coming in. Now we want to orchestrate and actually use that data coming in to be able to do predictions and output that back out to our Power BI so we can, again, know how long people are going to stay in the hospital. And so let's look here as an example to show you that data factory. So this data factory, I believe, is running every 15 minutes, and I'll check when it gets up. Yep, so it runs every 15 minutes. We take data in from our Azure Data Lake store. We have 4 activities that's happening here. So we're doing 4 different SQL queries, and then we're outputting those results back out. And so in this case, I'm not going to go into too much detail here, but I just want to show you the example of different results we're doing here. So we have a join phase where we join different data sets together. We have a scoring phase where it's a SQL script that calls out to that machine learning model and gets predictions. Then we also have these 2 processes, one that pulls out a certain set of data that we're going to visualize in Power BI, and then another process that appends all of that data to this huge historical data set that we can do things like retraining or updating more analytics over time. So this is our Azure Data Factory, which is orchestrating that data movement, how often things happen. And then the last thing is just the Power BI, which there's a lot of talks on Power BI at this conference, so I'm just not even going to talk about it. This is Power BI. So the next demo I'm not going to go into the portal in the interest of time, but I'm just going to talk through a couple more demos. And again, these types of materials are available in that Cortana Intelligence gallery. So I showed Azure Data Lake Analytics with integration with R, what we can do there. This is another example solution where we're trying to predict the likelihood of readmission. So when you're going to discharge somebody from the hospital, if they actually are going to end up being readmitted, especially for a set of conditions, the way the law is written today is that the hospitals actually get charged a lot of money if people get readmitted. There's these fines that happen. So in addition to having to pay for people the outcomes aren't as good, right? The person's coming back to the hospital actually has to pay a fee because those people came back. So understanding the likelihood of readmission is a very important business use case. And they also want to be able to do that recommendations and insights part where we want to be able to say, okay, this person is likely to readmit, but maybe there's nothing we can do about it. We could keep them longer, we could do interventions, but there's just something about their underlying condition that there's not much intervention we can do. So even though we know that they're likely to readmit, it's not going to actually impact our action, right? But then there's other cases where we might know, okay, they're likely to readmit, and this intervention program is really likely to work well for them. So we should do that intervention program. It costs a certain amount of money, but the likelihood is we're going to prevent that readmission, so we should do that for that person. So in this example solution, we show not only the machine learning model, but an example of when you know these different efficacy numbers and intervention, how you can actually use that in addition to the machine learning model to actually recommend what you should do as a result. To show you the Power BI briefly about what the example built on top of that solution, we have an expected savings from the intervention program. So some people are likely to save money and others are likely not to save money. They might be likely to remit, but again, knowing those different factors, we can make different decisions. So this is again an example solution where in this case we're using Spark on HD Insights. So this is that MapReduce type framework. In this case we're using a PySpark, so a Python-like language on top of Spark to do a machine learning model and predict back out. And a lot of the layers are very similar. We're again using Stream Analytics to do that real-time processing. We're again using Azure Data Factory to orchestrate. But in this case we're using Spark on HD Insight. There's a lot of different analytics solutions, and you might be like, okay, now there's so many, what do I do? Yeah, that's definitely a tough problem. A lot of it comes from what works well for your organization. Perhaps you already are using Spark, you already have a lot of code written in this type of language, or maybe you're starting from scratch with these cloud technologies and you can move to Azure Data Lake. And there's a lot of pros and cons, and there's a lot of documentation on how to choose between these different options, but just want to give you a flavor of what's available today. And next one, I'll often get the question after this. I have been talking a lot about the cloud and what you can do with Cortana Intelligence Suite and Azure Data Lake Analytics and HD Insight, and these are cloud services, so available on the Azure platform. We do have analytics on-prem through SQL, so SQL are services. We have an example solution in the Cortana Intelligence Gallery where you can deploy a cloud version of this, but it's basically all the technologies also available on-prem. So in this case, we use the Azure Data Science Virtual Machine. This is this really nice virtual machine for data scientists with all the data science tools pre-installed. So you can install this Data Science Virtual Machine, then with SQL Server with R services integrated. And then you can also develop R models or develop forecasting machine learning models and deploy them within the SQL Server. And then again, do things like visualize in Power BI. So again, this is another example solution. This one's around length of stay, and it's available in the Cortana Intelligence Gallery for you to check out. Okay, good. I got through the material fast enough that I can go back to this. So now I want to touch just for a couple of minutes on deep learning. There's this really popular field in the last year or two. It's really actually been around for a very long time, but it's become more and more popular, and it's even been talked about in on things like NPR and in the news. And there's been a lot of advances in deep learning lately, and so I want to just touch on some examples of what you can do with this types of technology. So we're talking about population health management, what you can do in the healthcare space. There's a Kaggle Data Science Bowl this year. I think it might have just closed, but it was just earlier this year, where Kaggle's this data science competition platform run by Google where you can actually compete in data science. So not only are data science nerdy, they actually compete with each other to be the nerdiest. And in this case, they're actually trying to determine whether a patient has cancer. So there's all these images. These images are labeled on which image is actually cancerous or which is not. And what we wanted to do is we wanted to create a solution that would run in less than an hour, do it really fast, and come in the top 10%. We weren't shooting for one, but just do this fast enough and do it well. And how do we do these things? Because often in data science, being able to iterate and come up to the solution quick is often more important than spending lots of time to come up with the ideal solution. So this is based on work by people on my team. So what we're doing is we're using the Data Science Virtual Machine. Again, it's that nice machine available on the cloud platform, running with a GPU, which is really important for deep learning to be able to do that a lot faster than you can do with CPUs. And we're using the Microsoft Cognitive Toolkit. This is a framework for deep learning. It's similar to TensorFlow, if some of you have heard about that. And then we're using a light GBM for classification. So this is just a certain algorithm that predicts classification type things, which is basically a binary outcome like 0, 1 when you're trying to predict that classification. And then we use deep neural networks. So what is a neural network? What the heck is this woman talking about? So deep neural networks are based on artificial neural networks, and I'm not going to go into the details of them, but basically you have a set of data, right? And you want to turn that data into what you want to predict. So I have like this image, for example, and I want to predict, is this image cancerous or not? Now that image is a ton of pixels. How the heck am I going to do that? And what the magic of deep learning and deep neural networks is, we take all of those individual pixels and we feed them through different functions at different layers. So we have one layer where we feed it in, it does all these functions, and then it outputs out. Now, rather than just doing one function, we do this many times with many different functions, many different layers. Now, obviously, you have to figure out, well, what the heck function do I do, and how do I figure out those functions? How do I figure out the parameters? And those are what all the fancy algorithms are doing for you, is they're figuring out what should be done at all of the different layers. And lots of research has been done about what's the ideal architecture of deep learning, how many layers should I have, how many hidden nodes, and all of these aspects. But at the end of the day, we're taking data in, we're feeding it through a series of functions, and we're getting an output back out. And there's been a lot of research, especially in just the last few years, about what's the ideal architecture of these deep learning networks, especially for image is a really popular field for this. Now, there's been some work that's been done in 2015. Microsoft released ResNet, which is just a little bit deep. It's 152 layers. It's doing some really neat things with like residuals. And again, I'm not going to go into the details, but really accelerated what we can do with deep learning and really getting amazing results back out. So what we're doing in this example is we're doing what's called transfer learning. Now, in the deep learning space, when you've created a machine learning model, and in machine learning in general, usually you create a model for a specific problem, like that length of stay prediction or that population readmission. But what you can do in deep learning is you can actually do this thing called transfer learning, where you've created a model that's trained for something in particular. Now, in this example, there's this really classic ImageNet data set, which is available on the web, which is basically lots of different images of lots of different stuff. Like this image is a cat. And it knows it's a tabby cat, and there's lots of these images, and then you train the deep learning model to learn this image is a tabby cat. And so that is that ImageNet data set trained with the deep learning model. So obviously, whether that image is a tabby cat or not is not very relevant to does this person have cancer. But what we're doing is we're actually taking that machine learning model and we're actually taking the majority of what it's learned, the relationship is, how it learns to actually analyze that image, and we're then applying it to a new field. And so here, what we're doing is we have this ImageNet data set. It's learned all these relationships. It has lots of layers of these different functions that are applied to that image. And what we're doing is we're taking all of those layers, all of those functions, how it's taking all those input pixels and putting them back out to that output. And we're taking all of that machine learning model except that last layer of functions, which then says this is a tabby cat or not. And we take that model, everything up to the penultimate layer, and we then are going to apply it on our new data set coming in, which is those images. Now, the ImageNet and the model was learned on 3 channels, red, green, and blue. So what we're doing is we're taking 3 batches of images from the patient. So we have 3 different images, and we're applying those to the different channels like it was red, green, blue, only it's just black and white, it's just 3 different examples. And we're applying that through. It has to have the same width and length of the image, so because we have that machine learning model that takes the input and gets the output, so we need the same number of inputs, et cetera. So here we're taking that in, and we're applying that model for everything until that last layer. Now, once we do that, we're going to get all of these numbers basically out of that model at that penultimate layer. And what we then do is we use those numbers, we just treat them as columns in a data set that we're going to predict with. So rather than those individual pixels, which obviously don't matter to whether somebody has cancer or not, like that is black or gray or white, that doesn't matter. But this machine learning model has learned how to analyze all these data and turn those into features that are actually relevant. Like this is the shade at this location and things like that. And then we apply a standard classification model to predict whether somebody has cancer or not. So this is called transfer learning. And so we're actually able to get in the top 10%, do really pretty amazing results with this data set and actually predict whether somebody had cancer or not with pretty high accuracy, just using this simple technology and then using the power of the cloud to do the compute for us. So we've published all of the material online, so you can get a sense of how we do all that, as well as a blog on that framework, so you can definitely check that out. And again, the slides will be available, so you'll have all of the links. Now, I have only a couple of minutes left, so I just want to give a quick overview of what we talked about today. Thank you guys for being here today. So I talked about data science and software, how they're changing healthcare, especially IoT, cloud, and machine learning. And then I talked a lot about Azure Data Lake in particular, how that can help transform businesses, especially in healthcare space, although I think a lot of these topics that I talked about today are really relevant to a lot of different industries. Azure Data Lake Store, Data Lake Analytics, and HD Insight, those are the 3 different components of Azure Data Lake. Really, the extensibility model is really interesting with the R support that I showed you guys, as well as the ease of use, those use SQL type queries, and then of course connections to the rest of the Cortana suite, things like Stream Analytics and Azure Data Factory, which I showed you were very important to an end-to-end solution. And really, a major takeaway is please take advantage of those solution templates to get started, to understand how these things work. There's a lot of material available in addition to the individual services documentation. And again, some just more references. So with that, thank you guys so much. I can take a couple of questions, and then as a plug for my next session, because I'm speaking again right after this, is Data Science Superpowers session. I actually need to look up where it is. I think it's on the lowest floor in the 4 to 5. So we're speaking about data science superpowers, some more nerdy stuff about data science, in case you're not totally sick of me. Thank you guys so much. Yeah, question. I can take a couple questions. Yep.
Yeah. So when you stand up a computation instance, so is that configurable or is it serverless?
Yeah, so the question was, when you stand up these services, are they configurable? So they are definitely configurable. Like, you could go into that use SQL query, for instance, in that solution and redo that query or redo all of that material and then redeploy it. So they're deployed in your own subscription. So they're definitely by not any means like SaaS type applications or anything. It's definitely services that are in your own subscription that you can configure.
So you mean the hardware we're using, we can configure that, right? So
oh, the hardware. Yeah, you can't configure the hardware. So these are past services. So all of that's done for you under the hood.
okay.
Yeah. Question over here. Yeah.
Relative to other areas where if it's a black box and it gets it right or wrong, the consequences are different. So
Yeah.
can you put more work towards explaining or visualizing what the ML is doing?
Yeah, that's a great question. So the question was about explainability of models, especially in healthcare and in a lot of industries where it's really important to be able to say why things are happening the way they are. So a lot of the technologies I was showing today are really open source technologies. So it's not like they're necessarily black box because they're Microsoft or anything, but at the same time, it is an important consideration to make sure you choose algorithms that are explainable if that's important for you. Now, deep learning is very hard to explain no matter what type of model you do. There's lots of things that are happening, and it is very black boxy. Now, that's usually okay for things like image analysis because it's very hard to build computer vision or a lot of these frameworks without building those type of models. But for a lot of other types of situations like length of stay prediction or readmission, it's definitely very possible and doable to use algorithms that are much more explainable using things like linear or logistic regression, where you can understand the weights and how the different factors, and then do analyses like what's the importance of these different factors. So all of that is definitely doable. The technology that I was showing today, we're leveraging open source machine learning. So it's just about choosing the right types of tools right types of algorithms and right types of approaches to enable that.
It's more like if a radiologist misdiagnoses someone, you can have other radiologists look and tell you what they're thinking, even if they get it right or wrong.
Yeah.
That's what I mean.
Yeah.
It's just harder to do.
Yes, absolutely. Absolutely. So the question was like, when a human makes that decision, you can have, and we actually talk about this a little bit in my next talk in Data Science Superpowers. Often it's important in these types of solutions to still have a human in the loop. So a lot of this stuff is not about eliminating the human altogether, but it's about making things more efficient. And so thinking about that business process is also very important. We don't want to just create all this technology for the sake of creating technology. We want to make sure that they're used by the right people and they can create impact. So doing things like inserting a human into that loop so they can confirm that person did have cancer, that didn't. And that's often really important because then you want to do things like retrain that model. We don't want to just have one model. We want to retrain it and want it to get smarter over time. So having those humans in the loop is really important. I think I have to cut it here because I have to run to my next session, but my email is up here if people have more questions, and thank you guys so much.